Hello everyone, this is Solve for X, and for today's topic, solving linear equations. Now, before we get started, we must first understand that the goal of solving a linear equation is to find the value of x, or any given variable that satisfies the said equation. So, to show this, let's start with something simple. So we have, x plus 1 is equals to 5. Now, normally we just by inspection we can say that um if we add 4 to 1, we get 5, right? But let's try to use a step-by-step method in order to solve for the value of x. So, whenever you're solving a system of no, not system, sorry. Whenever you're trying to solve a linear equation, we must first try to isolate our given variable, in this case, x. So how do we isolate this variable? So we have to transfer all the other constants to one side. Constants being our counting numbers, in this case 1 or 5, to the other side of the equation and and isolate x. So how do we do this? So if as we can see here, our operation here is addition. So what is the opposite operation to addition? If you said subtraction, and you are correct. So what we want to do here now is to sort of get rid of this plus 1 right here. So what we can do, let me change color of pens, is subtract both sides by 1. So what we will get is 1 minus 1, that's simply 0. So we leave x alone, equals to 5 minus 1, which is 4. So now we have our value for x. And to check if our solving is correct, we can plug our value of x back into the original equation. So if we have x is equals to 4, we plug the x value, or we simply substitute. So we'll have 4 plus 1 is equals to 5. 4 plus 1 is 5, so we'll have 5 equals to 5. Since 5 is indeed equal to 5, then we can say that our solving is correct. Now let's try it. Let's try this again with a different example. Let's say we have x plus 7 is equals to 24. So if you remember from our previous example, we must first isolate our variable. Now how do we isolate our variable here? As you can see here, similar to our previous example, 7, oh no, sorry, the operation here indicated is addition. So we have to subtract both sides in order to get rid of the 7 so that we can isolate x. So how do we do that? If you said subtract both sides by 7, you are correct. So now we subtract both sides by 7. We copy x. 7 minus 7 is 0. 24 minus 7 is 17. So now we have our x value. If you want to check, we can substitute our x value back into our original equation. So given that x is equals to 17, we will have 17 plus 7 is equals to 24. 17 plus 7 is indeed 24. So we are left with 24 is equals to 24. Since the left side is equals to the right, our solving is correct. Now, if you don't want to do the adding or subtracting of both sides, there is a rather shortcut method that we can do here. So let's have another example. So let's say we have x minus 7. Let's try x minus 7 instead. Is equals to 24. Now, normally, what you would do here, uh, similar to the previous problems, is that first we take note of what the operation is in order to isolate x. So normally what you do here is that you would, sorry, is add 7 to both sides in order to get rid of this 7, sorry, and, isolate x. However, if you do not want to do that, if you don't want to show your solution, or if you don't want to go through all the go through the steps for every single problem that your teacher might give you, what you can do is something we call transposing. So what we can do here is that we transpose, otherwise known as moving a constant to the other side here and changing its sign. So if we take note of 7 sign here, it's negative, right? It's negative. So if we change the sign, what does it become? If you said positive, then that's correct. So if we move 7 to the other side, we copy x, and we are left with 24 plus 7. So therefore, our x is now equal to 31. If you want to check if the solving is correct, you may plug x back into our equation, but for time's sake, I will not be doing that. Now that we know how to isolate x if it is being added or subtracted by a certain constant, let's say now it's being multiplied or even divided by a certain constant. So let's say we have, let's move to a different side of our board here. 2x is equals to 24. So now we cannot apply the transposing trick or the adding and subtracting trick that we utilized earlier because we have a product of 2 and x. So there is no addition, there is no subtraction, and it's now multiplication. But we can still make use of taking note of what the operation is. So since we know that this is a product of 2 and x, we know that they are both being multiplied. So what is the opposite of multiplication? If you said division, then you are correct. So what can we do in order to isolate x here? Because we want the value of x alone, what we can do here is we divide both sides by 2. So if we divide, let's take a look at the left-hand side first. If we divide 2 by 2, we're left with 1, and that is simply x. 24 divided by 2 is 12. So now we are left with our x value of 12. And similar to the previous problems, you may plug x back into our original equation in order to find out if you really got the correct answer. So let's try that now. So given that x is equals to 12, we will have 2 times 12 is equals to 24. 2 times 12 is 24. So we are left with 24 is equals to 24. And since 24 is indeed equal to 24, our solving is correct. Now let's try a similar question, or rather equation, but instead we will have the division operation instead of multiplication. So let's say we have x over 2 now, or x divided by 2 is equals to 24. So now, what is the operation being indicated here? So as I said earlier, it is division. We have the quotient of x and 2. So how do we isolate x in this case? So if we remember the steps from earlier, we have to take note of the operation, which in this case is division, and um, utilize the opposite operation. So what is the opposite of division? It's multiplication, right? So what we can do here to isolate x is to multiply, sorry, let me change the color, multiply both sides by 2. So why do we multiply both sides by 2 in this case? If we look at our left-hand side here, let's focus here because that is where our x value is, or our variable is, sorry. This is the same as 2 over 2 times x, sorry, times x. If we divide 2 to itself, or any number divided by itself, we simply get 1. So this cancels out, and this is simply 1. So we are left with x. Let me erase that. Sorry. And 24 times 2 is 48. So now we have our value for x. If we want to check, we can plug x back into our original equation again. So we will have 48 divided by 2 is equals to 24. 48 divided by 2 is 24. So we are given 24 is equals to 24. And since 24 is indeed equal to 24, our solving is correct. So with that out of the way, let's try solving some more, not necessarily complex, but harder examples. So we are given the linear equation, negative 6x minus 4 is equals to 20. So what would be the first step here? First, we can add both sides by 4, or we can simply do the transposition technique. So either way, you will still get the same answer. So we'll get negative 6x. 4 minus 4 is simply 0, equals to 20, plus 4 is equals to 24. So now we have a product of negative 6 and x on the left-hand side of our equation. So what we can do here is, if you remember a previous example, we can divide both sides, correct? However, do we divide both sides by 6 or negative 6x? Actually, both ways are valid. However, it would be better, or rather it would be faster for us to multiply both sides by negative 6 instead. Let me show you why. So first, let's do the division by negative 6. So we divide both sides by negative 6. Negative 6 divided by negative 6 is simply 1 times x. That's simply x. Equal to 24 divided by negative 6 is negative 4. So that is our final answer. But what if we divided by both sides by 6 instead? Let's try that. So we'll have negative 6x is equals to 24. Then we divide both sides by 6 instead. Negative 6 divided by 6 is negative 1 times x is negative x. Is equals to 24 divided by 6 is 4. So as you can see here, we are left with negative x is equals to 4. If we were solving for negative x, this would be our final answer. However, we want to solve for x alone. Negative x is not x. So how do we get rid of this negative sign? So since this is simply a coefficient of negative 1, x has a negative coefficient of 1, we can either multiply or divide both sides by negative 1. It's up to you really. You will still get the same answer. So let's say we divide both sides by negative 1. Negative 1. Remember that this is a coefficient of negative 1. Negative 1 divided by itself, negative 1, is equals to 1 times x, that is simply x. 4 divided by negative 1, is negative 4. And we have our final answer. As you can see, both ways yield the same answer. However, if we divide by positive 6, we have that added step of having to multiply or divide both sides by -1 in order to get x. So I guess rule of thumb here is if you want to avoid that added step, you take note of the sign of the side with the variable, and you either multiply or divide both sides using that same sign, right? So if this was 6, let's say this is 6, this was just simply 6, we divide both sides by +6, right? But since this is -6, we divide both sides by -6 instead. So let's try one more example here. -8y plus 6 is equals to 22. So we can subtract both sides or simply transpose 6 to the other side. So we're left with -8y is equals to 22 minus 6 is 16. 16. So now, to isolate y, we can divide both sides by -8. We divide both sides by -8 because we have a negative sign on the side where our variable is located. So -8 divided by itself, -8, is simply 1 times y. We are left with y. 16 divided by -8 is -2. Sorry, let me fix that. -2. And you have our final answer. You may feel free to plug -2 back into our equation in order to see if the answer is correct. And that is the end of our solving linear equations video. I hope you managed to get a good grasp on how to solve linear equations. If you have any questions, feel free to drop them in the comments below. See you, and I hope you have a good day.